Assalamualaikum. My name is Husna Nadah binti Zainuddin, and I will present about properties of ionizing radiation. In this section, we will look into the types of radiation, ionizing radiation, properties of alpha, gamma, and beta radiation, properties of ionizing radiation, and the last one is the penetrating power of radiation. Firstly, we will go through the introduction. In 1895, the German scientist Wilhelm Röntgen discovered X-rays. Then, a few years later, French scientists Marie and Pierre Curie discovered radioactive radium. There are various types of radiation around us that are indicated in the electromagnetic spectrum. It is ranging from radio waves, which is the low energy, and to gamma radiation with the high energy. Next, I stated here the example of use of electromagnetic spectrum in our daily life. We can see that for each wavelength, there are a specific use of the radiation. For example, for radio, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays. Each of them has their own specific characterization and use. Next, the types of radiation. We have two types of radiation, which is ionizing radiation and non-ionizing radiation. For ionizing radiation, the wavelength is shorter than 100 nanometer, and for example, we can see that it is X-rays and gamma rays. Also, in ionizing radiation, there is a particle radiation. The particle radiation is the beta particle, alpha particle, and neutron particle. For non-ionizing radiation, the wavelength is longer than 100 nanometer, and for example, it is microwaves and radio waves. Next, ionizing radiation. Ionizing occurs when electron in the inner orbit of an atom receives sufficient energy to escape from the influence of the nucleus, like the first picture I stated had. Then this action will cause the formation of a positive and negative ion, like the second picture. As a result of ionization, characteristic radiation emitted when an electron from an outer shell falls in to take the place of the electron that was ejected earlier. Ionizing radiations cause ionization when they pass through matter. Alpha and beta particles and gamma rays are emitted spontaneously from the nuclei of unstable atoms during radioactive decay. Examples of ionizing radiation are alpha and beta particles, gamma rays, and X-rays. Noted that in radioactive materials, radiation is emitted continuously in a regulated manner, as we can see in the picture attached here, that it is always regulate, and this regulation cannot be stopped. Also, it cannot be switched off. Next, for X-ray tube, typically X-ray are produced by the sudden deceleration of the electron in the strong field of the target nucleus. Next, the machine is energized, and only then X-ray machine will emit the radiation. But when the high voltage is disconnected, no X-rays are emitted. Then we will go through the properties of alpha, beta, and gamma radiation. For alpha radiation, it is strongly ionizing but can be stopped by paper or skin. For beta radiation, it is also strongly ionizing but is more penetration than alpha particle. For gamma particle or gamma radiation, it is have a very poor at ionizing, about 1:1, but very difficult to stop because they have a very high penetrating power. In this slide, I attach attach the illustration picture of penetrating power radiation for each of the radiation. As you can see, here alpha can be stopped by a piece of paper, beta radiation can be stopped by human hand, gamma rays require a lid in order to be stopped, but not for neutron. Neutron only can be stopped by several feet of concrete because it has a high penetrating power. So, that is all for me. Next, I will hand this presentation to the other presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ayumi Zaliana binti Amir Mahmud. My metric number is 2020452146 and I will be presenting radiation detection. Ionizing radiations cannot be detected by human senses. Appropriate instruments are necessary to detect and measure them. All methods of ionizing radiation detection are based on the ability of them causing ionization directly or indirectly. 4 types of radiation instrument. First, we have portable radiation monitor, area radiation monitor, personal dosimeter, and monitors for internal radiation contamination. Portable radiation monitors. They are battery-operated handheld meters used at radiation facilities and work sites to ensure that the radiation level is within the limits specified in the Radiation Protection Ionizing Radiation Regulations 2000. Some of the examples are Geiger counter and scintillation counter. Portable radiation monitors usually consist of a probe or detecting head and the associated electronic circuitry. The probe contains the detectors such as GM tube, ionization chamber, and sodium iodide crystal. Next, for area radiation monitor, the purpose is to give an indication of the external radiation levels present in an area where ionizing radiations are present. An alarm would be triggered if the level exceeds a predetermined value. It is designed to respond to gamma radiation and may use either GM tubes or ionization chambers in the detecting heads. For personal dosimeters, it is to determine how much radiation exposed to radiation workers in the course of their work. Some of the examples are thermoluminescent dosimeter, TLD badge, quartz fiber electroscope dosimeter, QFE, and beeper. For the first one, two lithium fluoride chips are mounted on a card and encased in a special holder. It is worn on the body for a month or two. The amount of radiation would be recorded on the TLD chips. The use card then change after 1 or 2 months. After that, the used card are heated up in the TLD reader, and the amount of light emitted shows the amount of radiation absorbed by the card. Thus, it is the amount of radiation the worker has been exposed to. Next, for the QFE dosimeter, it is for non-destructive testing worker, NDT worker. It contains a quartz electroscope in a small ionization chamber and optical system. It gives an immediate reading of the dose received by the wearer, but it is less accurate than other dosimeters and easily affected by shock. How to read QFE dosimeter? Point at a light source to look through it and read the scale. An extremely sensitive fiber electrometer type voltmeter and a small volume of air is used to measure the total amount of radiation which the instrument has been exposed. Lastly, for beeper, miniature GM tubes in small instruments which are carried in the pocket. It trigger a beep sound depends on the radiation level. The sound increases in frequency when it exceeds a predetermined dose rate. Last but not least, monitors for internal radiation contamination. Measurements for internal contamination radiation can be done on body excretions. Urine and feces are collected to measure excreted radioactivity. Excretion rates are calculated to determine the total intake. So, we have the comparison between methods of assessing internal radioactivity. For direct counting, we directly measure the human body, while bioassay, indirect measurement. And for direct counting, need to spare time to receive direct measurements. While bioassay, we submit samples such as urine, stools, and others. Direct counting mainly target materials that emit gamma ray, while bioassay able to measure all radioactive materials. For direct counting, short measuring time using the instruments, while bioassay chemical analysis takes time. And lastly, for direct counting, accurate dose assessment, and bioassay large margin of error in results of dose assessment. So there are some positive and negative for both sides. And these are the example of instruments for measuring internal exposure: stand-up whole body counter, scanning bed whole body counter, chair whole body counter, and thyroid monitor. That's all from me. Thank you.
Assalamualaikum and hi everyone. Today I will talk about the last subtopic from the Nuclear Physics, Radiation Physics PHY 370, which is radiation safety. I am Nur Alia Hanis binti Asmi. So next, the elements that we will discuss in this presentation is radiation safety, exposure dose limit, radiation exceedance, and emergency procedures. So, what is radiation safety? Radiation safety is the combination of safe practices and precautions designed to promote safety when working with or near radiation. This follows the motto ALARA, and it stands for as low as reasonably achievable. Occupational exposure limits, the Radiation Protection Ionizing Radiation Regulations 2000 has been specified the dose limits for radiation workers and members of public. This is recommended by International Commission on Radiological Protection (ICRP). There are two categories of persons recognized by ICRP in recommending individual dose limits. First, the adults who are exposed in the course of their work, and second, members of the public like us. Dose limit for radiation workers is designed to avoid the deterministic effect from occurring by keeping those limits below the threshold for deterministic effect, and the recommended dose limits are 20 millisievert per year, averaged over defined periods with the condition that the effective dose shall not exceed 50 millisievert in 1 year for 5 years. The purpose is to optimize the protection, and the exposures are remaining as low as reasonably achievable, taking into account economic and social factors. ALARA principle. Dose limit for public like us is 1 millisievert per year. Higher effective dose values may be permitted in 1 year. So, women who are not pregnant, dose limit is equal to men dose limit. But for pregnant women, the equivalent dose limit at the female abdominal surface is 2 millisievert for the remainder of the pregnancy. Next, we will go to the radiation accidents history. This happened in the early hours of April 26, 1986. The reactor at the Chernobyl nuclear power plant in Ukraine exploded, creating a radioactive storm in the atmosphere and contaminating much of Europe with radioactive fallout. And this happened because of human error. The arrogance and heroism displayed on the ground as engineers, firefighters, doctors, and government officials worked to contain the debacle and the cover up and elongations that followed. The pictures show the human side of the story and ordinary men and women risking their lives to escape complete catastrophe. The radiation accidents that we can consider are unexpected or uncontrolled of high-level ionizing radiation, loss of control of unseen radioactive material, accidentally released into environment, and or a person that enters a high radiation field accidentally and contaminated skin or clothes. So, what we can do when we are in the situation of the radiation, when we are affected by the radiation? First, everyone is evacuated from the disaster area. Second, affected areas, including those with radiation levels above 25 sievert per hour, are off limits, and warning signs are posted at all entrances. Third is rapid action to mitigate hazard from radiation accidents. Then provide temporary containment and take precautionary measures to monitor and decontaminate all affected people and their areas. And lastly, ensure that unacceptable contamination of a person's skin or clothing is removed. Lastly, from me, just a general reminder, be aware and be safe from radiation. Thank you.